for my statics class and a good review for strengths, but we're going to talk just briefly about internal forces and moments. So we've been looking external, and we've been looking at loads on beams and loads on compound frames, okay, and trusses, and all sorts of cool things where we've been able to find reactions, okay, both external and reactions where we have pinned connections, So how does this load that I apply here, okay, we're just going to call it L over 2, how does this load go from here to here? Do you think that we just have a force on the beam and then we magically have a reaction? Do you think internally there's force along this beam inside? Maybe some bending moment? Okay, there is. And we're going to be heading towards where we can actually write equations for the shear and moment, how it's distributed along the length of a beam. It's super important. When we get to the shear and moment videos, I will show you some really cool drawings of beams, internal workings of concrete beams where we have the steel that's in the tension region of the beam and how you can look at that and almost pick out what the shear moment diagram is. I know I'm rambling. I'm tired. I'm sorry. Okay, so internal forces. The biggest thing that we need to understand is that internal forces and moments are really kind of talking about the behavior of the beam, okay? Unlike a reaction, when I load it, I can push up and I can tell you that at AY, we have a P over 2 up. I have units on there. With internals, we're going to have positive beam notation. We are not going to show up or down or positive or clockwise or counterclockwise rotation. We're actually going to use positives and negatives because it's describing the behavior. So if I were to cut this beam right there and look internally, I could possibly have a normal force, which we've been working with normal forces, looking normal in compression and trusses. That's what we've been looking at, is a normal and compression force in a two-force member. We could have beam shear, okay? And we could have internal moment. When I'm coming from the left to the right, this is what I have to assume. I have to assume we have positive moment, positive normal, positive shear. Positive shear causes a clockwise rotation, okay? This positive moment is looking positive. It would cause curvature of my beam, if you can just imagine. I'm putting this moment on my beam, and it would cause smiley face curvature is what I call it, where I know I've got compression top, tension bottom. If I'm coming from the right side of the beam towards the left, my normal is pulling to the left, my shear is now going up, and my bending moment is going towards the right, okay? So this is why I cannot show arrows. Both of these normal forces are showing tension. They are showing, maybe I have a rubber band in here, but I doubt it because I'm no longer in my office at work. Oh, this looks stretchy. Okay. So if I have this beam and I'm looking internal normal, normal positive means tension. See, I'm stretching that in that direction. Okay. As I'm working my way from right to left, I also am showing normal is pulling away from the beam in tension. Okay. If we said that it was a negative normal, that would let us know we are looking at compression. I'm compressing, and if I'm compressing on this side, I would be pushing to the right over here, compressing over here. Okay? So, sorry, these are really kind of bad examples, but there you have it. So, when we look at this, I know that a positive normal is tension, which again, that's what we've been looking in trusses, and a negative normal means compression. As I'm designing, it's super important to know whether we have tension in our members or compression, especially if we have materials that have a different yield stress for tension and compression, okay? Positive moment is going to make my beam look like a smiley face. And negative moment is going to make, oh, I just drew it the same way, didn't I? Kind of a habit creature of habit. Okay, so negative moment is going to make my beam pop up, kind of like a rainbow. So when I'm looking at this, I know that I have compression, tension. This is going to be super important as you move into strengths of materials and then concrete or steel or structural analysis or whatever you might have after this, okay? Both of my shears cause clockwise rotation, okay? Positive beam notation. You have to use this. You have to use this or your answer is wrong. Never, ever, ever, never, ever show a direction. Never. Don't do that. This is what we do for reactions. Internal, we use positive and negative. You must assume it in the positive behavior when you get started, so that when you get a positive normal and you call it tension, we all know it's truly in tension, okay? So you can find the follow-on videos. There should be 4 examples you can print off of Canvas, and I'll work each of them individually.